For AI, find how many different 5-digit numbers can be formed using the digits 1, 2, 3, 5, 7, and 8 if each digit may be used only once in any number. Since we are talking about number arrangement, we are going to use permutation. The formula is NPR equals to n factorial divided by n minus r factorial. N is the total numbers we have, which is 1, 2, 3, 5, 7, 8, so 6 total numbers. R is the digits we're going to use, which is 5. So, 6 factorial divided by 1 factorial equals to 720. For AII, how many of the numbers found in part I are not divisible by 5? So first, let's find the ones that are divisible by 5. So I will be preparing 5 slots for the 5 digits we're going to use. Since we are first finding the ones that are divisible by 5, the last slot will be filled with the number 5. This means that only one number is available for the last slot. Since we have 6 total numbers, and one number is already used in the last slot, it means that we can fill the other slots with the 5 remaining numbers, the 4 remaining numbers, the 3 remaining numbers, and the 2 remaining numbers available. So let's times it all together. 5 times 4 times 3 times 2 times 1 equals to 120. These are the ones divisible by 5. But since the question is asking for the one that are not divisible by 5, we are going to subtract 120 from our answer in I. We will get 600. For AIII, how many of the numbers found in part I are even and greater than 30,000? So first, I'm going to prepare 5 slots again for the 5 digits we're going to use. The last slot can be filled with the even numbers available, which is 2 and 8. The first slot can be filled with 3, 5, 7, or 8. For my first choice, I'm going to be taking 2 as my last number. This means that I have 4 choices for my first number. So, remember that I have 6 numbers available. I already used 1 number in the last slot and 1 number in the first slot. This means that for the remaining slots, I can fill it with the 4 remaining number, the 3 remaining number, and the 2 remaining number. So 4 times 4 times 3 times 2 times 1 equals to 96. Next, I'm going to be preparing another 5 slot. The last slot will be filled with the even number, 2 or 8, and the first slot will be filled by 3, 5, 7, or 8 since we are finding the ones greater than 30,000. This time, I will be using 8 as my last number. If I use 8 as my last number, I have only 3 choices left for my first number. Again, I have 6 total numbers available. I already used 1 for the last number. I already take 1 number for the first number. This means that I can fill the other slots with the remaining 4 numbers, the remaining 3 numbers, and the remaining 2 numbers. So 3 times 4 times 3 times 2 times 1 equals to 72. 96 plus 72 is 168. For B, the number of combination of n items taken 3 at a time is 6 times the number of combinations of n item taken 2 at a time. Find the value of the constant n. First, the formula of combination. NCR equals n factorial over r factorial times n minus r factorial. So let's write down the equation. On the left side, we have n items taken 3 at a time. N factorial over 3 factorial times n minus 3 factorial. This equals to 6 times n items taken 2 at a time. So 6n factorial divided by 2 factorial times n minus 2 factorial. Next, I will be cross-multiplying the equation. 2 factorial is 2, so 2 times n factorial times n minus 2 factorial equals to 3 factorial times 6 is 36, so 36 times n factorial times n minus 3 factorial. I'm going to cancel n factorial from the equation, and I'm going to divide everything by 2. This means that we have 18 on the right side. Next, I will be dividing everything by n minus 3 factorial. Now I am going to be expanding the left side. N minus 2 factorial equals to n minus 2 times n minus 3 times n minus 4, so on and so on. N minus 3 factorial equals to n minus 3 times n minus 4 times n minus 5, so on and so on. This means that I can cancel out everything except n minus 2. This will leave us with n minus 2 equals to 18, so n equals to 20. Thank you.